Yeah, so just give me one second. Yeah, sure. Yeah, good morning, good afternoon, good evening, everyone. So just quick introduction about me. My name is Aditya Rautaray, and I'm working as a solution architect at CVS Healthcare in United States. So today, I'm going to take you in a research space, right? So I was working with that research like almost like 3 months ago. I started that research, and so I it is quite interesting because I'm trying to describe couple of different technical stack that people are using nowadays. So one of the technical stack it is something generative AIs, and everybody is quite interesting about it. And the other one is like your Internet of Things. Uh, so if you look at the titles that what I'm working on the research paper side, it is a natural language control for social Internet of Things using a generative AIs. So I mean, why it is so required? I mean, what exactly we'll try to achieve it here. So I'll start with a very punchline of this research paper, like what we achieved, or what kind of results that we achieved from this research, that what we have done. So if you look at this, 94.2% intent accuracy. So I'll definitely go into this intent accuracy, how it is, and how we measure those values. Then you can also look at the hallucinations rate. Like we reduce like almost 77% of hallucination rates. So when we combine a generative AIs with the Internet of Things, right? And we also reduced the I mean, when you talk about the violations blocked, it is something like unsafe actions. What basically we like every time, like when you do some kind of generative AIs, there are a lot of unsafe actions that can be possible, right? So that how we have reduced with this kind of guardrails that I'll talk about in my next slide. So, so here is the scenario. So just think, I'll just put a questions to everybody, and I'll start my, giving you more details about it. So just think about a scenario. So like like we are living in a home, right? So we have like a lot of, like nowadays, multiple, everybody has some kind of a smart TVs, smart lights, even like, multiple smart robots, right? So, and everybody is now that using those smart devices, right? So let's say like you walk in your home, and it is a very long day, and it is very it's a very bad day, I would say. And you say your voice assistant that, hey, I had a very rough day or maybe a bad day. Can you make my house comfortable? So that is a very good question, because you are very frustrated because day is very bad. So now you wanted to make your home in a very comfortable way, so that at least you can take rest or something like that. And you just ask those questions to your device, right? So in that case, what happened now? The device will think for something, and just say, I mean, I don't know like what you were what actually looking at, or maybe it will answer something that device not found, right? So which is not a good things, right? Because you ask something, but at the same time your voice assistant said that I'm not able to do anything, I'm not able to help you on this. So that is what the core problem here. So nowadays everybody is using Alexa, everybody is using Alexa, Google smart homes, even people are using also Siri, right? So those applications are basically based on some kind of pattern match and exact phrases, right? It has basically some kind of a rules, and that rules is basically trained by those devices. And if you'll just ask some of the questions, then automatically that device will answer whatever it is trained before, right? But what you do, like if you add something like some kind of emotions to that, or maybe you change your phrase, you change your system, or maybe you just change your language in different other language, right? So in that case, what happened, that your system will going to be collapsed. So the published benchmarks, still what we have at this point of time, the platforms. basically scores only 42% of your natural multi-device commands. Like when you give a commands, so that will be only a 42% will be is a kind of the result that we observe till now. So and that is what like we need to work on. And also, if you give a like a complex scenarios or maybe a complex statement, you ask something which is not properly trained by this device, then we observe like there will be 10% of your complex scenarios that has been taken care, or 90% it is failed, it is collapsed, right? So what is basically the different rules that why this devices are getting collapsed, right? Why it is not properly answer your questions and all. So there are three different rules, right? So one is like rigid rules, right? So rigid rules, very tough rules. That is exactly what phrase that is going to be answered by your device. That is already pre-trained. And if you do some changes in that rules, then your device will break. Now there is one more issues with that kind of devices. Like your Alexa. Let us say you have Alexa, one of the device. Alexa cannot talk to another Alexa which is present in your ground floor, right? So here what happened? Like device don't talk with each other because they don't know like where the other device is and how the internet connectivity is, like what kind of connectivities you have, because one device doesn't know about the other device, right? So that is another issue why it is collapsed. And the other thing, other criteria is the AI makes things. So what happens, right? So without mapping your all devices into a home, like let's say you have a home and you have like a multi-storage building, and there are multiple smart devices that you have integrated through Wi-Fi, but here your device does not talk to a AI enabled other device which can control your unsafe activities. Like so let's say some, I'll talk about more on this what is unsafe activities. But here what happened, like one device is not talking to another device or not using the AI guardrails to stop some kind of unsafe activities. So that is what like millions of users, like I mean if you look at millions of users using all Alexa, Google Homes and Siri, those are like very renowned services. People are using it. Those are like devices, but unfortunately they don't have those kind of capabilities at their home. So now, what is the big questions behind that? Like, so what is our research starts, right? So now the question is, can we build a system that can understand your natural language or any complex commands or any emotional commands, and how this the I mean in general, I mean in a general way, how this human beings is talking with each other, right? Because they don't know, like they can use a profane word, or maybe there are some of the words they use which is not accepted by other peoples, right? There are multiple things, right? So in that case, just think that a human being is saying something, but that is now is understood by a LLM models, which is by your natural language processing or any complex commands. And can we integrate those things, right? So then the research idea came, like if why can't like we let us combine these different ideas. So I pursued a couple of ideas here. So one is like idea A and idea B. So idea A is like, let's introduce a social graph netting component here. And of course, then idea B, it is like all language model, which actually supports your natural language processing. So, so what idea says? So give a device a social network. So whatever devices you have, so let's give a social network and integrate everything in a kind of a social network graph netting table. And it's very similar, like if you look at a LinkedIn, like everybody is like created their profile in LinkedIn, right? And there are like company profiles, there are like software developer profiles, there are there are multiple kind of like profiles people have created, and they're part of those teams, right? Just think in that way. You have like smart lights, you make a one profile. You have like smart televisions, you make another profile. Then I'll go through in details like in our next slides. And similarly, use AI and understand your context. So what is this? So I mean, in this idea base, what is basically does? So you use any of this natural language processing. In my research, I used a GPT-4 model. But what this language model does it is basically you gets your command, understand the emotional tones, and implicitly like give a intent out of it, right? Just to understand what is the intent out of it, right? And without guessing anything, right? So that is what, I had these two different ideas. Now, if you combine these two ideas, what my research is, let's group all these devices as part of a social graph netting component, and also you integrate a GPT-4 model or any natural language processing model, just to make sure your devices are connecting with a your device connecting profile, right? So if you go to the next slide, so now I have I asked, like when I started the research, I asked few questions to before I start this research, right? So I have four questions I have listed down it here. So one of the question is how does the generative AIs substantially outperform like when it is a rule-based system uh, versus like your natural commands, right? So it is something like how this accuracy versus rule based, right? So rule based, I already described. I mean explained. Rule based is something like your Alexa, Siri. So these are like all rule based engine. I mean rule based engine, right? So now the second question is how does the social graph impact the accuracies and the hallucinations, and it is the most important impactful component because that is very much required for this research. And then and the third one, which is like the guardrail effectiveness. So guardrail is something, some kind of there are a lot of unsafe actions like everything in your at home, but you need to understand like if somebody is like hacked your system or they try to do some lot of unsafe command that you are giving it. So those things that can be now, is it something that if you deploy guardrails when you get that generatives, I mean when you get some kind of generation of this your generative AIs, can we stop those unsafe actions or make it as a low false positive cost, right? So these are something that we asked, I asked these questions like whether we can be improved with this guardrail effectiveness. And the third one is like your deployment barriers. So currently, what happened, like everything that has been deployed in a cloud environment, and we also look at like whether this is a scalable approach or not, right? So that is like one of the questions I asked like when I started this. Uh, experiments, right? Okay, so this now we'll talk about the system architectures, and which is very required to understand what is the system architectures looks like. So let me walk you through like the how the command flows, right? So let's say like you say something that, hey, can you dim the lights? You have like multiple smart lights at your home, and you just say your device that, hey, can you dim the lights? Okay, so in that case, what happens, right? So the layer one is basically you speak, and the device will listen that. And then what the device will do, it talk to your GPT-4 models or any natural language models. And then what it does, it understand like what exactly you want to try to do. So it's basically your LLM model hears your words on the statement, understand that, and then it will try to find a meaning of it, like what exactly you wanted to do it. So from my question, it is like you wanted to turning up the lights, right? That is what like the intent that we got it from the LLM models. Now, once you got that, now the second thing is that you need to find the intent, right? That is the second layer. So in the intent, what happens, like you have to decide the system extract, like who is going to do it and what is going to do it and where we can do that, right? There's three questions that we need to ask in this particular layers. So when you talk about the dim the lights, right? So dim the lights means like in which floor, like let's say you have multi-stories building, you have like let's say you wanted to dim the lights maybe in the ground floor, right? So in that case, like this system will find it like where we need to do that, okay, and who is going to do that. So this is what like the second layer does. Now the third layer is basically it is the core of this particular architectures, which is like you have to create a social graph managers. Like it is basically a core layer which instead of guessing something that which slide where it is, so it is basically look at your graph table. So I'll talk about like what is the social graph, that how we create it. But yeah, you need to talk about to the graph table, and in the graph table it is something that is a matching of your profiles to the smart devices, right? So that is basically this layer will go to an inquiry about it, just queries about it, like what lights, where it is, and who is owner of these lights. So everything will get the details, and then it do and dims the lights, right? So that is something that this graph will provide the informations to it. Now the fourth layer is basically you need to understand, like you need to plan it, right? So like what are the safety rules, if there is any safety rules, or if there is some kind of guardrails that you have defined, right? So that is like something plan mode. Here what happened, like the orchestrator layers is going to plan everything, like what system and what action we need to do, where is to do, and just it's very similar like a supervisor agent, right? So that's something that it will do, and it will give you the step-by-step action plans. Okay, now once this steps-by-steps action plan has been decided, now there is the execution layer. So there will be a device which actually connected to your Wi-Fi or to your any internets, and which actually now takes the actions from the layer 4, and then it does like whatever the action plan that you have decided. So this is the pretty much like where the complete system architecture and how we do. Now let's like go to the social graph. As I said, like this is more important because to understand like how you define the social graph netting, we call it as a social graph netting, where like you have to group them devices in different types. So if you look at like I in my experiment, there are multiple relationship types, but I just put it as like a five of my from my research. So where what we did, like we have like different sibling profiles. So siblings means like you have smart lights, you have like smart bed lights, there are multiple lights, so those are siblings, right? So can we make it a one group? Okay, similarly there is a co-locations, like let's say you have like multiple storage, so can you make them in a like a level one, or maybe like bedroom lights, or maybe like your sitting room lights or something like that. So can you make that kind of co-locations group? Similarly the ownership, so let's say like you are the owner of those lights, maybe your multiple people are staying, and everybody has different TVs or maybe televisions, right? You have like smart televisions, so maybe who is the ownership of that? Similarly the co-work, like collaborated of the task, like it is something like how like how these devices will be maybe one device is depends on another device, so that also you can make it as a collaborated task group. And similarly also make it as a same manufacturer, the parental group. So parental group, like let us say from like all TV, your smart lights, everything from a GE companies, right? So in that case, like you'll make everything in a one group. So that is very important, and this is something you have to do it everything in a NeoJ. So we used a graph DB, which is like your Neo 4J. So we use that graph DB to profile, making the profile for this particular social graph netting purposes. So then what we observe, like without a social graph, so let us like if you don't want to go with a social graph, right? So it's basically what it does. So LLM always relies on a generic work knowledge, right? So LLM, like yeah, of course that you are using LLM, but LLM always try to look at the words, the statement that what you have used, and is try to do a queries to that LLM and get some kind of intents, right? And in that case, what happened, like your hallucinations rates will be almost 16.8%, which is like really more. At the same time, there will be a lot of unsafe action. There is no guardrails that has been you can integrate it with this kind of without a social graph. But if you go with a social graph, right? So definitely you know what devices that you need to connect, right? In the topology, because you have created a topology in this graph DB, and you can look at the device, what exactly in what devices I wanted to do a actions. Similarly, you can also look at the devices ranking. You can rank those devices. Like let's say you have like multiple smart TVs. Like okay, you can rank those like what is more priorities, what is less priorities, and all. So you can make the ranking, and then when you develop this social graph changes and all, so then you will find that the hallucinations completely coming down to 3.8%, which is really a good it's mostly complete. I think there is one more slide. Sorry, there is one more slide. It is going to be complete. Yeah. So how we tested the system? We have like 500 real-time scenarios. Three scenarios that we tested with multiple, with 40% emotional, commands and automation task and all. And if you look at the what is the key we identified hallucinations rate that has been decreased to minus, 77%. And of course, the unsafe actions blocked as 78.3%. Okay. So yeah, so these are like limitations that when we do this, experiments, there is a single domain that we tested, and there is a cloud of dependencies, and also there is like what are the data that we have used? Those are like all synthetic data. So that is some of the limitation, and we are working on this. Yeah, so these are like all future directions, that what area that we need to have a large language model will work on, like your SLM deployment, which is like your gamma models, or some of the models. There is also real-time user evaluation that also need to work on. Multi-agent coordination, it is not part of this research, so that probably we need to work on. Yeah, so the takeaway of this research is mostly like make it as a social grounding of your all IoT devices that you are deploying. Yeah, there will be a 94.2% is completely depends on zero shots integrations. Then domain specific guardrails, yeah, you integrate the domain specific guardrails. And of course there is a latency issues, and for that probably we are going to work on the SLM deployment part. Yep. So yeah, so that's it from my end. So now is the question time. Thank you so much.
Thank you so much, sir, for your